Okay, this is my second video on the booklet 2 of revision notes, and in the last video I had discussed a few questions from the revision notes, and I'm taking up a few other questions right now. And the numbering of the questions that I discussed in the last video were according to older version of the revision notes. This is based on the latest 2017 version of the revision notes. So apparently they have changed the question numbers. So keep that in mind, and just you know just check out which number question this is in your revision notes. This was 15 in mine, and it's 13 in the latest ones. Okay, so let's just solve this. Okay, so it says a population is subjected to a force of mortality of mu x is equal to e to the power of 0.0002x minus 1. Okay, and it is asking us to calculate the probability that a person who is aged 20 exact right now, and this person is aged 20 exact right now, and we need to calculate the probability that he survives up till the age of 70. So basically we need that the person aged 20 right now survives for 50 more years, right? That is what we need. Okay, for this, basically the definition of TPX is required because they have given us the value of mu here. Okay, mu x is given, and mu x is not constant, it is dependent on age, it is a function of age. Okay, so we need the definition of TPX. So TPX is basically equal to e to the power of minus going from 0 to t. Okay, mu x plus s ds, right? So that is your definition of TPX. It's just saying that going from age 0 to t, going from time 0 to t, this force of mortality does not happen, right? That therefore there is a minus sign. So we have discussed this definition time and again, and this is similar to discounting using a force of interest. So I don't think you have a dispute with this definition. So according to this definition, this would be e to the power of minus integral of from going from 0 to 50 of mu. Now x plus s, x was 20, so 20 plus s ds, right? So this is your definition for this thing. Now let's just evaluate this. This would become e to the power of minus going from 0 to 50. I have to put this in place of this definition of mu x. So it becomes e to the power of, now instead of x I have got 20 plus s. So it becomes e to the power of 0.000. Now there are four or three zeros. Let me check. Three zeros. Okay, so 0002. Okay, 0002 into 20 plus s. Okay, and there is a ds, of course, and this is integrated. Okay, ds is not upstairs. Let me fix this. Okay, yeah. So this is the 20 plus s. Okay, and minus 1. This is your definition for mu x 20 plus s, right? I just replaced the x with 20 plus s because it was mu x, and I've got mu 20 plus s, and this is ds. So this is integrated over this range. So let's just integrate it. This just becomes e to the power of minus. Now if I try to integrate this thing, e to the power of something can be integrated as e to the power of 0.0002 into 20 plus 0.0002 into s, right? But here this part, it is just a constant multiplied with this term, so we don't care about it. In fact, you can write them separately too. This into e to the power of this into e to the power of this. Okay, so the only factor coefficient of s here is 0.0002. So I just divide by 0.0002. I've just integrated. Integral of e to the power of t at dt is equal to e to the power of at upon a, right? That's what I have applied here. So, and minus, instead of this thing 1, I'll get an s. okay, and this would go from 0 to 50. Okay, so this is what you get basically here, and it's not very complicated, it's pretty straightforward. Now if you will put these values 50 and 0 in place of these things, so you will get e to the power of, if you will solve this, you put 50 first in place of s and here, and then you put 0. Okay, so you will basically get minus of e to the power of 0.0002 into 20 is 0.004, plus this is 0.0002 into 50 divided by 0.0002, okay, minus 50, and if I put 0 in place of this becomes minus 0 would be e to the power of 0.004 upon 0.0002. Okay, so that's something I have. 0 would be gone, and since this was negative, this will now become positive, and I'm putting 0, so 0. Okay, so this is e to the power of this thing, and it becomes e to the power of, if we will solve this, so this would be e to the power of 0.45224. Okay, and this is negative, of course. Okay, 45224. So this comes out to be 0.63620. So what we did here was just applied the definition of TPX directly, and we got this answer. Okay, so this is your answer for this. Now the next part is we need the probability that this person dies between the ages 60 and 70 exact. Okay, so now what we want is we want him to die between the ages of 60 and 70 exact. So this is basically, the person is age 20 and you want him to live up till 60 and then die by 70. Okay, so this is basically a deferred death probability. So 40 deferred, um, 40 deferred, 10 Q20. This is what I have, or I can simply write this as 40p 20 into, once he becomes 60 he has to die within the next 10 years, so it would be 10q70, 10 10q60. Now he's 60. Okay, so this is what I have: live for 40 years from 20 to 60 and then die within 10 years, so now he's 60 and he has to die by 70, so 10q60. Okay, so this is basically what I have. I have a deferred probability, right? So now I can actually easily evaluate this. If you will evaluate this, this would be evaluated using that very definition of TPX that we used just now. It would be going from minus um, 0 to 40, and 0 to 40 e, now the definition of mu was e to the power of 0.0002 into 20. Now I will have a 20 plus s obviously here, and ds, right, minus 20 plus s minus 1 and ds, right. This is what I had, right. Now instead of going from 0 to 50, I have gone it's going from 0 to 40, right. This was the definition. Yeah, this was my mu. Okay, yeah, this if I write it clearly for you, it is e to the power of going from 0 to 40 mu x plus s ds, right. This is the definition of TPX. Nothing extraordinary about this thing. So this is this thing, and this part, it becomes, see, this is the probability of actually, wait. So there is one interesting thing we can do here. See, So now what you need to multiply with this is 10q60. You can actually do three things here. First thing you can do is you can write this as 1 minus 10p60, right? You can do that. So if you do that, you will get 1 minus e to the power of minus going from 0 to 10 e to the power of 0.0002 into 60 plus s minus 1. Okay, this is what you have, ds, and the back bracket is closed. Okay, so basically this is what you will have for 1 minus 10p60, because 1 minus 10p60 becomes 1 minus e to the power of minus integral from 0 to 10 mu 60 plus s ds, right? That is what it becomes, and then I just put the value of mu 60 plus s and I just multiplied it. So now basically you can solve this. You can solve this to get your answer. I won't tell you the other complicated things. They've used a method to evaluate this probability in the book. The way they have done is they've said that the probability of dying between 60 and 70 is basically equal to the probability of surviving till 70, that is 20 survives till 50 minus 40p20, right? This is what they have written. So basically it's saying that the probability that a person age 20 will die between 60 and 70 is equal to the probability that he survives till 70 minus the probability he survives till 60. So this is the way they have done, and then they have actually used this result from the first part. So this basically becomes e to the power of minus integral from 0 to 50 mu 20 plus s ds. This was your result from the first part, minus e to the power of minus 0 to 40 mu 20 plus s ds. So you can basically use the same integral too, and this is actually an easier method, but this should strike you, right? If this strikes to your mind, this is in fact the easier method, or you can also apply what I applied here, right here. Okay, so you don't need to do anything here. You just need to evaluate this integral, and then you need to multiply it by 1 minus this integral, and we know the rationale behind this. We just deferred, we just evaluated it as a deferred annuity, or you can just take the difference of two survival probabilities to get it. So either way you will get the answer. So let's move on to the next question. This integral I'm leaving it up to you. Okay, next is question number 10 from the new revision notes. This is basically question number 12 in my revision notes. Okay, so let's solve this. This says we need to calculate these two, and it would have been straightforward. This is just a term assurance and this is just an endowment assurance, but for the basis they have not given us CM92 or ELT15 table. Rather they have given us the LX values, and they are just saying that LX for any value of x is equals to 110 minus x, and this makes sense because Lx is obviously a decreasing function of x, so I can just put the value of x in order to get the Lx values. So let's just try to evaluate this, and there is a trick here. If you get the trick, you get the answer, and such questions are not expected to repeat in the exam, but still you should know them. They are not very repetitive kind of questions. Okay, A4120. Okay, so I need the value of a term assurance. So the definition of this thing is going from it goes from k is equal to 0 to 19, because n minus 1, right? That is what I have. K is equal to 0 to and v to the power of k plus 1, okay, into k deferred qx. So this is your definition for a temporary annuity, and obviously x is equal to 40 here. So that is what I have. Okay, so let us just try to evaluate this. So basically what is happening here is I've got k deferred qx values, and the definition for k deferred q40 or k deferred qx is equal to um, it is equal to kpx into qx plus k, right? All this is saying is that the person has to live for k years first, and then he has to die within 1 year, right? So if I try to see this elaborately, because I have L values here, so I need to convert this in terms of D and L. Okay, so this is equal to Lx plus k over Lx, right? And this is equal to D x plus k over Lx plus k. If you actually see it, this is just the probability of person dying in 1 year, and D is the number of people that die in a particular year, and L is the persons alive at the beginning. Actually, I have discussed this definition when I was discussing chapter. I had just started discussing chapter number 3. Okay, so I had discussed this definition. If you don't, it is just Qx is equals to dx over Lx. Okay, because simply because see, I'll prove it to you if you have forgotten this. See, px is equals to Lx plus 1 over Lx, right? This makes sense to you because this is the number of people surviving 1 year. So basically qx is equal to, okay, if I talk about qx is equal to 1 minus px. Okay, so it is equal to 1 minus Lx plus 1 over Lx from here. Okay, so if I take an LCM, this becomes Lx minus Lx plus 1 over Lx, and Lx minus Lx plus 1 is dx. So this is dx over Lx, right? So I hope you get it now. So qx plus k, because this is the number of people that die in a particular year. So qx plus k is equals to dx plus k upon Lx plus k. So this Lx plus k cancel, and this is dx plus k over Lx, right? So this is what I have here. So now instead of this, I will put this integer. Okay, so this just becomes k going from 0 to 19 v to the power of k plus 1 d x plus k, meaning d 40 plus k over Lx L40, right? So this is what I have here. Now if I talk about d40 plus k and things like this, let's talk about this in detail. If I talk about d40 plus k, what is it? So d40 plus k is L40 plus k minus L40 plus k plus 1, right? Now if I refer to this definition of these two guys, because see, uh, this is the number of people that die in the k plus 1th year, right? That is what they are. Okay, so in the k 40 plus kth year, at the age of 40 plus k, between 40 plus k and 40 plus k plus 1, right? So if I put the value of these two from here, see, I have been told that Lx is equals to 110 minus x. So I can actually write these in that term. So this becomes 110 minus 40 plus k. Okay, and this guy becomes 110 minus 40 plus k plus 1. Okay, so let's just apply this, and okay, let's do that. This is in one bracket. Okay, so let's, if I apply this, this becomes 110 minus 40 minus k. Okay, and this becomes minus 110, and minus minus become plus, so plus 40 plus k plus 1. Okay, and if I cancel these out, 110 110 40 40 k k. So this is equal to 1 basically. For d 40 plus k is a constant, which is 1. Okay, so that is an amazing thing for us. So since this is a constant and L40 is also a constant, I'll take them out. So this becomes 1 over L40 and this part it is just k going from 0 to 19 v to the power of k plus 1, right? So this is what you have here. Now if I try to see this is 1 over L40 into sum over k going from 0 to 19 v to the power of k plus 1. Okay, so this is what you have here. Now the amazing thing is that I can actually evaluate this directly. So this becomes L over 40. This is equal to, if I start putting these values, this is equal to v to the power of 1 plus v square plus v cube going up till v to the power of last 19 plus 1, so 20. Okay, so these are basically 20 terms, and this is equal to 1 over L40. This can be written in annuity terms. Okay, so this is annuity payable in arrears for 20 years, so it is A20, right? So now I have everything that I need, and I can actually evaluate this. This becomes 110 minus 40. Okay, 1 over 60. This would be 1 over 60, and this one is A20, that is the sum of all these. So this becomes 1 minus v to the power of 20 over I. I is something, I has to be something. Okay, we have got the value of all of these. They've given all the, this is 1 over 60, and this becomes 1 minus 1 point, let's take the interest rate. I think it was 4%. Yeah, it's 4% per annum. So yeah, 1.04 to the power of minus 20 over 0.04. So this just becomes, oh, okay, I'm sorry. This is 70. This is 70. 110 minus 40, 70. Yeah. So this becomes 70, right? So these two, it becomes 1 over 70 into 13.5903, and this just becomes 0.19415. Okay, so that is your answer for the temporary, for the term assurance. Now I need the endowment assurance value. So I need A 4020, right? So this is basically equal to A 4120 plus 20 P40 into v to the power of 20. Now these two terms are easy to calculate. So this just becomes 0.19415. Okay, plus this term, it becomes L60 over L40. Okay, so L60 over L40, and this is v to the power of 20, 1.04 to the power of minus 20. Okay, now let's just evaluate this. This is 0.19415, and this part it becomes this is 110 minus 60. This is 110 minus 40, and this is 1.04 to the power of minus 20. Okay, so this comes out to be 0.52014. Okay, evaluate this, we'll get this answer, and that's all for this question. Okay, this is another question which is very similar to what we just discussed. Okay, so let's try to evaluate this one. This says for a particular species of animal mortality, the rate of interest, the mortality and the rate of interest are shown according to the following basis, and we need A35. Okay, that's what we need, and what we have is Lx is equal to L0 into e to the power of minus 0.15x. Okay, so that's what we have, and we have got interest is equal to 5%, so I is equals to 0.05. Cool. These are the two things that we have, and I actually need this. So let's check this out. Okay, A35 basically is equal to A315 plus probability that a animal or whatever it is of 3 years of age survives for 5 into V5. Okay, so this part is easy to calculate. Okay, so now I have got two terms to evaluate here, this one and this one. Okay, this is pretty straightforward. Let's do this one first. let's do this first and then we'll do this. Okay. So what I have to do is calculate the value of A315. Okay. So this is the same as the sum of k going from 0 to n minus 1, that is 0 to 4, v to the power of k plus 1 into k deferred q and x is equal to 3. So k deferred q3. Okay, so this is what I have here. Now, as we did in the last question, we are going to apply almost the same adjustment here. I'm going to calculate the value of this k deferred q3. Okay, so k deferred q3, this is basically equal to probability that a person age 3 survives for k years and then dies within 1 year. So q 3 plus k, right? That is what I'll have. Okay. Now, now the thing that we need here is I need to actually find the value of this, and I have to use this that they've given that Lx is equals to L0 times e to the power of minus 0.15 x. Okay, so that's what we know, and let's use this. So this is basically equal to L. Okay, I've got L 3 plus k over L3, right? That's what you have. Into this one would be L 3 plus k minus L 3 plus k plus 1 divided by L 3 plus k, right? So these would be as follows, and these would cancel out, and this is what I have. Okay, so I'm left with, to write it more clearly, it is L 3 plus k minus L3 plus k plus 1 divided by L3, right? So these are the things that I have here. So this would come out to be L0 into e to the power of minus 0.15 and 3 plus k. Okay, so that's what you'll have here instead of this thing. Plus this would be L0 into e to the power of minus 0.15 into 3 plus k plus 1, right? Because I'm calculating L 3 plus k plus 1, so instead of x I've just put this value here. I put 3 plus k, and this would be divided by L0 into e to the power of minus 0.15 into 3, right? So that's what we have here. Now let's try to solve and simplify these. So out of these three, I can actually take L0 common upstairs, and what I can take common is e to the power of minus 0.15 into 3 plus k as common. Okay, so inside I'll just have a 1. Okay, there was a minus sign here. Here I had a minus sign. Right. So basically what comes out is this term, and inside I have a 1 minus e to the power of minus 0.15. 3 plus k is gone, so 1 is left, so just this term. Okay. And downstairs I've got okay, I've got L0 into e to the power of minus 0.15 into 3. Okay, so L0 cancels and this 3 cancels with this. Okay, so what I have as a final answer here is e to the power of minus 0.15 into k. Okay, and this term 1 minus e to the power of minus 0.15. So this was my value for k deferred q3. I think that was the term. Yeah. Okay, so that's my value for k deferred q3, and I am just going to use it and apply it to that equation. So here instead of this, now I have got sum going from k is equal to 0 to 4. Now v to the power of k plus 1 is just 1.05 to the power of minus k plus 1, right? That's what I have, and this is e to the power of minus 1.5 k into 1 minus e to the power of minus 1.5, oh no, 0.1, 0.15 k into e to the power of 1 minus 0.15. Okay. So this is what you have here. Now some amazing things are going to happen here. I'm going to take some constants out and things like that. Okay, so let's do that. Here 1.05 to the power of minus 1 would come out because that is a constant, and apart from that this term 1 minus e to the power of minus 0.15 will also come out. Okay, so inside I'm just left with because these two are constants, I took them out. They were in multiplication with everything. K goes from 0 to 4. Okay, and 1.05 to the power of minus k and e to the power of minus 0.15 k. Now you will actually have to evaluate this further. This term is just okay. So if I evaluate this term, it just becomes what's out stays out, 0.15 minus 1, and okay, and this term is 1 minus e to the power of minus 0.15. So these two constants stay out. This term on the inside, I can actually make a small adjustment here. So what I can do is this is the sum of a GP here. I'll show you how it is a sum of GP. This is just if I put 0 in place of k, I have 1. If I put 1 in place of k, this is 1.05 into to the power of 1 into e to the power of minus to the power of minus 1 and e to the power of minus 0.15. Okay, plus 1.05 to the power of minus 2 into e to the power of minus 0.15, and this goes for I've got a total of from 0 to 4. I've got a 5 terms here. Okay, so if I evaluate this becomes 1.05 to the power of minus 1. This becomes 1 minus e to the power of minus 0.15, and inside what I have is um, 1 minus, okay, now I'm going to apply the sum of the GP formula. So sum of a GP Sn is equal to A into 1 minus R to the power of n over 1 minus R. Okay, so here A is equal to 1, the first term is 1, and the common ratio is 1.05 to the power of minus 1 into e to the power of minus 0.15, and to the power of n is basically to the power of 5 because there are 5 terms, divided by 1 minus 1.05 to the power of minus 1 into e to the power of minus 0.15, right? So I just applied the sum of a GP formula here, and this would give me this value, which would be okay. So this value, it comes out to be 0. 0.463508. Okay, so that's approximately this value, and now I will actually put this value into this equation. So it becomes 0.463508 8364, or let's call it 84. Okay, plus this is 5p3. So 5p3 is basically equal to L 8 over L3, right? That is what it is. So for this, the value would be equal to L0 into e to the power of minus 0.15 into 8 divided by L0 into e to the power of minus 0.15 into 3, right? That is what is given here, and this would be equal to e to the power of minus 0.15 into 5. So this becomes e to the power of minus 0.15 into 5, and this becomes 1.05 to the power of minus 5. So this would be these would be my terms, and my final answer would be it would be 0.83361 62. Let's make this 62. Okay, so it would be 0.83362. Okay, next thing we do is we start with a really interesting question here, and this is question number 44 from your newer version of your revision notes. So it says that we need to calculate A 473.25. Right, this is what we need to calculate, and we have to assume a constant force of mortality, that is CFM, between ages 73 and 74 only, and the interest rate is 4%, and we have got the mortality is PFA 92C20. So applying the CFM would mean that TP 73 would now be equal to P73 to the power of T for all the t's that are between 0 and 1, right? So I can actually apply this assumption this way. Okay, so now let us just try to understand what they want from us. Okay? So what they want is this value. This is basically your annuity that is starting in arrears at times 73.25. We want the value of this annuity at the age of 73.25. So there are basically four payments every year. Okay, since this is A4. Okay, so there are four payments annually, and I want to calculate the value of this annuity here at this moment. Okay, so basically, when are the payments starting? The payments are in arrears. So the first payment would be at 73.5. The next payment would be at 73.75, and after that the payment would be at 74. So I've got a payment of 1/4 here, a payment of 1/4 here, because since the annual payment would be £1 for this, the quarterly payments would be 1/4 of a pound, right? So I've got a payment of 1/4 here, and then 74.25, 1/4 here, and so on and so forth, going up till infinity. So what I can do is, actually I have to apply the CFM assumption for these two values at least. So these two payments I have to apply the CFM assumption, and later on I can make up a annuity that is payable four times a year without applying any assumption. So this annuity just becomes a due. You can call it a due for 74, right? So this is this whole life annuity that is starting at the, okay. So this is an annuity that we want, and we want its value at time 73.25. Okay, and there are two individual payments here. We want to discount them also to time 73.25. Okay, so basically there are three parts of this payment, and we want to discount them all and bring them till this time. Okay, 73.25. So let's go about doing that. So basically A 73.25 is basically equal to the sum of these three payments. The first would be A due, this is obviously 4, A due 74.4. Okay, this is something that I have, and this would be applicable once the person survives for from time 73 to 73.25 to 74. So I have to basically discount it for that factor. So he's 73.25 right now, and he has to survive 0.75 more. So I'm multiplying with this probability, and I have to multiply with the factor of v to the power of 0.75. You have to do it, obviously. Okay, and these other two payments, this one is 1/4, and this I have to discount from 73.5 to 73.25. Okay, so this is probability that a person age 73.25 survives for how long? He has to survive for 0.25 years. Okay, into b to the power of 0.25. Okay, so this needs to be discounted too. And the last one is obviously again a payment of 1/4. This one, this is happening at time 73.75. This needs to be discounted till 73.25, right? So zero point 0.5. So 0.5 P 73.25, right? And with a factor of V to the power of 0.5, right? So, so these are the three payments that I have. Now one more thing, okay? If I have a TPX, okay, if I have a TPX, uh, let's say I have to evaluate all these P probabilities here. What I can do a little adjustment. Let's take an example of this first one. So this is P 73.25, and on this side I've got a 0.75, right? So this is basically equal to, now on both of the sides I have a non-integer thing, okay, and this x always for applying CFM or UDD, uh this needs to be integer. Okay, so I can actually simplify this and write this in this form. I can write this as P 75, P 73 surviving for 1 year divided by P 73 surviving for 0.25, right? I can actually write this as these two things, because this all this is saying is probability of survival from 73.25 to 73.25 to 74, right? So I have just made it a quotient of this probability of survival from here to here, and then I've divided by this part in order to remove this, so just get this part. Okay, I've shown you this adjustment quite a few number of times, so I think you know it. This becomes P73, right? And this part, it becomes a P73 to the power of 0.25, because applying the CFM assumption. So this basically becomes P73 to the power of 0.75. That's how you can adjust it. You can ignore this decimal part here. You can just write these things as P73 to the power of whatever we have got in place of T. Okay, you can write this as whatever you have got in place of T, and P73 to the power of T. So you can directly write all of them as that, and you can ignore this decimal part. So that's what I'm gonna do for all of these probabilities. Okay, so this becomes this is A due 74, and I've got A 74 listed in your tables. So this becomes A due 74. I've got this listed in the tables. I have to adjust for this 4 factor. So since this would be smaller than this, there would be a minus sign, and m minus 1 upon 2m. So 3 upon 8, right? That's what I'll have. This becomes p to the power of 73 whole to the power of 0.75. That's what I did there and here again. and this is just the interest rate. The interest rate is given in the question as 4% per annum, as far as I know. I think it should be 4. Yeah, it is 4. Okay. Otherwise, we won't be able to solve it. So this is 4% per annum. Excellent. So 1.04 to the power of minus 0.75, right? Plus you've got a 1/4 here, and this is again I can ignore this part. I can just write this as P73 to the power of 0.25, right? And I can write this as 1.04 to the power of minus 0.25, okay, plus 1/4 into P73 to the power of 0.5 into 1.04 to the power of minus zero point 0.5. Cool. So this is something that you have here. Okay. So next thing, I'll just put these values here. I'll take them from the tables and put these values here so that we can get your answers. Okay. So let's do that. Let's take the tabulated values of PFA92C20 table. Okay, so that we can get the answer. Okay, let's do this. So putting these values, P73 is basically equal to 1 minus Q73, that is 1 minus 0.14973. Okay, and this becomes 0.985027. Okay, and A due 74 is given directly as on the right side. Obviously these are PFA tables and not PMA tables. 11.333. Okay, so final answer, if you will put these two values in this equation, this entire equation, if you will do that, you will get the answer as 11.011. Okay, so that is your answer. Please solve this putting these values for P and A due. Okay, that's okay. So there is this one last question that I want to briefly discuss. I'm not going to solve the entire thing. I'm just going to give you a fair idea of how to do it. Okay, so the first part of this question is pretty easy. It says to calculate the probability that a life now age 30 will die between 55 and 60 exact. Okay, using ELT 15 wins. So you just need to apply this formula directly. You just need to make the life survive from 30 to 55, that is for 25 years, and then he has to die within the next 10 years. So 10Q 55, right? So pretty straightforward. You can actually calculate these values directly from the tables. Okay. The second part requires us to calculate this same probability, but they've given us mu x value directly. Okay. So for doing that, see, this probability can be denoted as 25 deferred 10Q uh, 10Q30, right? That's what you can defer it. And this is equal to this into this. So this is equal to 25P30 into 10Q55. Okay. So this is what you have here. Now I need to evaluate this. Okay. So in order to evaluate this, this is very easy. You just need to apply the definition of these things. So dpx is basically equal to e to the power of minus going from 0 to 25 mu x plus t. So x is 30, so 30 plus t, okay, and dt. That's what you have here. And this can be written as 1 minus 10p55. Okay, so you can also evaluate this very directly. This becomes e to the power of minus going from 0 to 25 mu 30 plus t dt, and this one becomes 1 minus e to the power of minus integral going from 0 to 10 mu 55 plus t dt. Okay, this is one way of solving this, or you could have solved this as I have shown this to you earlier. You could have written this as the probability that the person survives for 25 years minus the probability the person survives for 35 years. Okay, so that would give you the difference would give you the probability of him dying between ages 55 and 65, right? So that would have given you the value, or you can solve it like this, whichever one you like. Okay, now all you need to do is put the mu x value into this or this equation, whichever one you like, and you can get your answer directly. So I'm going to write the equation for you, then the integral I am going to leave for you guys. This is e to the power of minus integral from 0 to 25. Now mu x plus 30 plus t, right? So this is 0 point triple zero, okay, no, double zero 5 into e to the power of 0.09, and x minus 20 means 30 plus t minus 20. So this would be 10 plus t basically for you in the next step, and this is your value for the mu, so dt. Okay, and 1 minus e to the power of minus going from integral 0 to 10 0.005 into e to the power of 0.09 into I've got the age is 55 plus t, so 55 plus t minus 20. Okay, so this is what you have here, and obviously a dt. Okay, so this is your answer. You evaluate these two integrals. Pretty straightforward. This would be e to the power of at, the integral of e to the power of at plus b. In fact, if I have a b constant here, doesn't matter. It just becomes e to the power of at plus b over a, the coefficient of t. If I'm integrating with respect to dt, so you can just directly apply this, and this would just be divided by 0.09, and then you will get your answers. Pretty straightforward. So both of these integrals need to be evaluated. This needs to be deducted from one, and this one needs to be evaluated directly, and you'll get your answer. So this was pretty straightforward. I won't do the manual labor here. Okay, so that's all for this video. Thank you. Okay, thank you, and have fun. Cheers.